This is a video from section 12.5 in a Calculus 3 class. The distance from the point x1, y1, z1 to the plane ax plus by plus cz plus d equals 0 is given by capital D is the absolute value of ax1 plus by1 plus cz1 plus d divided by the square root of a squared plus b squared plus c squared. And I actually derived this formula in another video for reference. Now, let's take a look at problem 71. In problem 71, we want to find the distance from the point 1, negative 2, 4 to the plane 3x plus 2y plus 6z equals 5. And I want you to look at how the plane is written. And it's very intentional. Over here, notice how we write the plane in the form ax plus by plus cz plus d equals 0. Now, that's not what we have here. And so we have to take 3x plus 2y plus 6z equal 5 and rewrite it as 3x plus 2y plus 6z minus 5 equals 0. Now we're ready to find the distance. Now notice, my x1 is 1. y1 is negative 2. And my z1 is 4. A is 3. That's the coefficient of x. My b is 2. That's the coefficient of y. C is 6, and lowercase d is negative 5. And now we're ready. So I'm going to take capital D, that's the absolute value of 3 times 1 plus 2 times negative 2 plus 6 times 4. And then I subtract 5. And I'm going to take that result and I'm going to divide by the square root of a squared, which is 3 squared, plus b squared, which in this case is 2 squared, plus c squared, which in this case is 6 squared. Now, this is equal to, now in the denominator, we have the square root of 49. And that's an equal sign, by the way. In the numerator, we have the absolute value of 3 minus 4 is negative 1. Negative 1 plus 24 is 23. 23 minus 5 is 18. So we get the absolute value of 18. And this turns out to be 18 divided by 7. And that's the answer to problem number 71. Let's take a look at problem 73. So we want to find the distance between the given parallel planes. Now, here we get 2x minus 3y plus z equals 4. And we get 4x minus 6y plus 2z equals 3. Okay. This is how it works. We have two planes, and they're parallel. I'm going to pick a point on the first plane, and I want to find the distance from that point to this plane. And we want the perpendicular distance, right? Straight down. So, in other words, first step, we want to pick a point on 2x minus 3y plus z equals 4. And it doesn't matter the point you choose, so make it nice and convenient. I'm going to choose the point 0, 0, 4. Nice, easy point. Now, let's write out what I'm going to do. So I want to find the distance from 0, 0, 4 to the plane in this case, it's to the plane 4x minus 6y plus 2z. And really watch what I'm going to do is I'm going to move the 3 over and then set this equal to 0. So in other words, we want the distance from the point 0, 0, 4 to the plane 4x minus 6y plus 2z minus 3 equals 0. So in this problem, a is 4, b is negative 6, c is 2. My x1 is 0, y1 is 0, and z1 is 4. And then, oh, by the way, my lowercase d happens to be negative 3. So capital D is. Now I'm going to take the absolute value of 4 times 0 minus 6 times 0 plus 2 times 4, right? Minus 3. Remember, again, this is all in absolute value. And then I'm going to divide by 4 squared plus negative 6 squared plus 2 squared. Now, in the numerator, we get 5. In the denominator, we get the square root of 56. But this is equal to 5 divided by the square root of 4 times 14. But remember, the square root of 4 is 2. And so, therefore, D is 5 over 2 times the square root of 14. Now, if I multiply the numerator and denominator by the square root of 14, I get the following. I get 5 square root of 14 divided by 28. And that's how we do problem number 73. 75 is a very interesting problem. It's a way to find the distance between two parallel planes. So it says, show that the distance between the parallel planes AX plus BY plus CZ plus D1 equals 0, and AX plus BY plus CZ plus D2 equals 0 is, I'm going to take capital D, and this is the absolute value of D1 minus D2 divided by the square root of A squared plus B squared plus C squared. And so the way this works is I'm going to choose a point on the first plane. Could I choose a point on the second plane? Absolutely. Okay, for the record. So I'm going to choose a point on AX plus BY plus CZ plus D1 equals 0. Now, we're going to think conveniently. So I'm going to choose 0, 0, and then negative D1 over C. So, of course, I have to assume C is not 0 for sake of argument. Okay? For sake of argument, assume C does not equal 0. Now, for the record, okay, it is possible for C to be 0. If C is 0, then either A or B cannot be 0. And whichever one is not 0, that's the X or Y that I would have solved for. So in other words, if A is not 0, I would have solved for X and set Y and Z equal to 0. If B is not 0, I would have solved for Y and set X and Z equal to 0. I hope that makes sense. So, but A, B, or C, at least one of them cannot be 0. Otherwise, there's nothing to do here. Okay. Now, let's come over here. So, we want the distance from 0, 0, and then negative D1 over C to the plane AX plus BY plus CZ plus D2 equals 0. Okay? So, from here, capital D is the absolute value of A times 0 plus B times 0 plus C times negative D1 divided by C, okay, plus D sub 2 divided by, and then I get the square root of A squared plus B squared plus C squared. So this is the absolute value of negative D1 plus D2 divided by the square root of A squared plus B squared plus C squared. And so this is the absolute value of negative 1 times D1 minus D2 divided by the square root of A squared plus B squared plus C squared. but this is the absolute value of negative 1 times the absolute value of d1 minus d2 divided by the square root of a squared plus b squared plus c squared. But isn't the absolute value of negative 1, 1? That's a 1, by the way. And if I take the absolute value of d1 minus d2 and multiply by 1, you get the absolute value of d1 minus d2. And then we divide by the square root of a squared plus b squared plus c squared. And we're done. So therefore, capital D is the absolute value of d1 minus d2 divided by the square root of a squared plus b squared plus c squared. Now, one thing I want you to notice here, what if I assume a doesn't equal 0? Okay? So if that were the case, I would have chosen the point negative d1 over a, 0, 0. Okay? Now, remember, the plane is ax plus by plus cz plus d2 equals 0. And again, not much going on because it's going to be the same idea. My d is the following. I'm going to get the absolute value of a times negative d1 over a plus b times 0 plus c times 0 plus d2, all divided by the square root of a squared plus b squared plus c squared. And this is the absolute value of negative d1 plus d2 divided by the square root of a squared plus b squared plus c squared. And notice I'm going to get the same answer if we assume a is not 0. And so therefore, if you want the distance between two parallel planes, you can apply this formula. We take the absolute value of d1 minus d2 divided by the square root of a squared plus b squared plus c squared. It's really very slick. So, okay, that'll do it for this video. This is a video from section 12.5, and we worked problems 71, 73, and 75. Thank you.